Hello and welcome. In this short video, we're going to review how to use the ECS Inc. Advanced Load Capacitance Calculator. This tool will allow you to more precisely identify the required values for your load capacitance crystals CL1 and CL2 that you will use with your microcontroller. But first, let's navigate to the Design Tools section and we'll find the Advanced Load Capacitance Calculator. From the home page, hover over Resources tab. Here, you will see a drop-down list of some of the available support resources that we have for the engineering community. You'll find articles, press releases, new products and highlights, design tools, reference designs, some technical guides. We have a video learning section. You'll find change notices and a link to our interactive catalogs. Then we're going to hover over Design Tools. Under this tab, you're going to see a list of tools that we have available. First are STM32 and SPC5 and STM8 crystal selection tools for ST microelectronics. Then you'll find the ppm to Hertz calculator, the Advanced Crystal Load Capacitance Calculator, and our 32.768 kHz Stability and Time Calculator. We want the Advanced Crystal Load Capacitance Calculator. When we click on that, it takes us to the landing page for the Advanced Load Capacitance Calculator. There are a couple of things we're going to need to have on hand in order for this calculator to give us the most accurate values for our caps. First is the CL value, load capacitance. This can be found on the manufacturer's datasheet, or it is typically included in the crystal part number. Next, we're going to need to know the C-in and C-out load capacitance values for our input pins of the microcontroller. These values can be found in the microcontroller's datasheet. If you don't know or don't have access for this value, leave the box value as not. This will represent zero capacitance. This will impact your results. They'll be less accurate if you don't have this information. Next is our PCB stray or C-stray capacitance. This is going to be design specific, and it's going to be based on your board layout, trace lengths, and other conditional items. This typically ranges from 1 picofarad, which is very good design, up to 5 picofarad, which is worse. They typically fall in that 2 to 3 picofarad range. So let's enter some values into the calculator. So select a value for box 1. For this, we are going to use 6 picofarad. It's fairly common today. Next, we're going to choose values for C-in and C-out. This is box 2 and 3. We're also going to use 2 picofarad for both of these. Next, box 4, this is our PCB stray value. So from the drop-down menu, pick the estimated stray board capacitance. As we stated earlier, this typically ranges from 1 to 5. Typical values are 2 to 3. Again, we will use a value of 2 for this. Next, we want to adjust the values in box 5, CL1, and box 6, CL2, until the box 7 CL matches the CL in box 1, and I'll show you what that looks like. Keep in mind, box 5 and 6 should always have matching values unless you are trying to pull the crystal frequency. So our goal today is to have box 7 have a value as close as possible to box 1, so 6 picofarad. So as we make our choices for CL1 and CL2, we see that the matching value continues to increase. And you'll notice in the boxes below for CL1 and CL2, These are going to be the actual value of the crystals that we're going to place on our board. As we can see, 4.2 picofarad is not quite enough. Let's jump that up to 5.1. We can see we're up to 5.5, so we have not matched our input CL value. We'll go to 5.6. That gives us a 5.8 value with two 5.6 capacitors on the board. So we're still 0.2 off from where we need to be. Let's see what happens if we go to 6.2. When we go to 6.2, we've actually passed the 6 puff value. We're at 6.1, but it's closer than the 5.8 value when we selected the 5.6 picofarad. So from this, we will use two 6.2 picofarad capacitors on the legs of our crystal. I hope this helped you out, and if you have any more questions, you can read the white paper that's associated with this. Thank you.